Hi guys, welcome back to the channel. This is Web3 Boy, and today's video is all about how a beginner can start with an audit, a fresh code base where there are problems that a beginner always faces, and I'm discussing this gamma staking, and I'm not going to discuss about the vulnerabilities here, but also what I want to discuss is how you can just navigate, right? So the first thing first, you just when you start, you just get all the scopes, all the files under the scope here, and I'll just tell you my strategy, how I started. So what I did is I started with this interface, which is interface log.sol. So I saw that okay, here all the structs, all the errors, all the events, and a bit of functions are here, and I thought that they aren't that much that much important for me, so I just moved on. I looked at lock list, not many function. I moved on, and then address pagination. So here they have a function. I just looked at it and understood like what this is doing. So they are actually trying to paginate address array, right? So like a page could have like 10 basically 10 different UN256 values that a page can contain, right? 10 or 20 or 30, whatever they decide, right? So they are trying to paginate it, right? So I understood, but I did not have like full context of it. But yes, after you try to understand the whole code base, you will have full context. So there were five contracts. So I looked at this. Okay, so all those were not very important, but there could be some things very important out of here too. So I just moved on. I looked at like lock list, and when you look at lock list, there are state variables, there are some events. You just take a look at the state variables, take a look at what are the events that they are emitting, and there are a few functions. So the function is add to list, then remove from list, okay, then update unlock time, and all these functions, right? So what I thought is I was trying to actually look for the contract and the function that is where core contract and core function. So whenever I start an audit, I try to find the core contract and the core functions where the user interact, right? Let's say, so I couldn't just see any any core contracts, right? Any core functions here. So I moved on to the log.source, and what I did was you can just click Control K plus O, sorry, Control K plus 0 in your Windows PC, and when you do that, all these function will just collapse. All these function will just collapse, and you can just take a high view overview of it, like what are the functions in the contract, and you can just look at it, right? And you can understand what basically when you are looking at the functions, by looking at the name of the function, you will understand what this function is trying to do, and by that you can also find out which one is the main function where the users are going to interact, or which one which functions are actually more important functions than the others, right? So starting out, just take a look at the state variables, right? So this is, let's say, base penalty percentage. So this is saying 15%. That means it represents the fixed penalty amount for unlocking early. That means what this function is doing, what this state variable is doing, it is basically fixing a 15% of penalty while you are withdrawing something, or like something like that. So get a high level overview of it. Time based penalty fraction, right? This is whole is like 100% representation of 100%. This default relock time is early exit disabled or not. It is a boolean value, so it will, like, if it is true, you cannot early exit, right? So something like that, right? Just try to understand what these are doing, right? And then when you have these in your back of your mind, you can just move on, right? So these are the mappings. Also see the mappings. So there are three mappings: rewards, that may be tracking the reward amount for users. Paid reward amount for user is reward paid, and reward depth amount is like reward depth, how much depth you have as a reward, right? Something like that. And after completing the whole code base, you'll have a better understanding of the code base. You'll try to you'll definitely have a clear picture of what these mappings and state variable will be doing. So initially just look at these variables and not not try to break so much into it, because these are not as important uh, later as they are now, right? So moving on, you can see the initialize function. So what it is doing is it is initializing the whole contract. So basically these are the things that has to be initialized. You can look at it, right? And then this is set penalty calci attribute. So sets the base penalty percentage and time penalty fraction for early exit. So when you are exiting early, there are like two things, right? Penalty percentage and penalty time penalty fraction. So basically it is a setter function, right? So it will be setting these two things, right? And also it has a if condition. So if this condition is passing, it will revert. Otherwise, it will go on and move. Do these things, right? Set these parameters. So these state variables are going to be changed in this function. So this is a setter function. And also, since when you look at this modifier, it is only owner, right? So the owner can only do this. And most of the times in the contest, these owners are actually not restricted, but they are trusted. So what contests are pretty different. So they say that, okay, the owner is trusted, so owner is believed to be putting the right values over here. So not many checks are needed here, because owner is trusted. So uh, if this was a private audit, it could have been different, right? Because you need to you can also suggest them to put a check, but yes, depends upon the client to client. Moving on, again there is this set default relock time. So it is also a setter function, so not many things to look. Also it is only owner. This is also setter function. This is also setter function. You have to understand what these are doing, but not while there are some parameters, there are some state variables that are very important, and you cannot just skip the setter function. Obviously, like if this is just doing this, and let's say there is a fees, right? And let's say this is only owner, but the owner is not restricted. Owner is not trusted, but he is restricted, right? So in that case, if let's say this was a fee setter function, and the owner is trying to set the fee that is more than 100%, in that case, that would be a problem, right? So, so based on the context of the contract, you have to actually judge whether these setter functions are important or not, and that will definitely come with time, not when you are very early in the uh, in your audit stages, right? Again, this is like set lock type info. So you have to see this set staking token. So the owner can set the staking token also. And yeah, I've put an audit tag but didn't submit it. It's because staking token one set can't be set again, since staking token is not equal to address 0. Check if the staking token is already set. I've put some audit tags, and for my better understanding. So wherever you are, this is also setter function, but once the staking token is already set, right, there is no way you can change it, right? So the owner can actually change the staking token, but since this is here, it will always revert, because what it is saying is staking token cannot be equal to either this or this, right? So the if this is true, you cannot set the staking token. because this is checking if the staking token is already set, and if it is already set, it will never allow you to set the staking token again, and that will be a problem. But in the context of this audit, they already mentioned it that the staking token will be the governance token and it can be set only once, right? So there's no need that this could be a vulnerability. But yes, I think this is a vulnerability, but it's okay. Like, it depends upon the context of the audit, obviously. Like, so if there are, like, let's say there are too many staking tokens, that the owner can decide whether there are 5 staking tokens, and owner can decide if he wants to change the staking token A to staking token B. But since the staking token is already set, it will always revert, and he won't be able to set the staking token. And in that case, this would have been a vulnerability, right? But that's okay. Moving on further, you are setting the treasury address. So this address is something like the address of the contract where all the external internal earnings will go to. So it is also a setter function. Then add reward function. Add reward is kind of add a new token to the list of the reward token. So when you are staking, this is set staking token. That means this is a staking contract. So when you are staking, you are expected to get some reward, and these rewards can be any token, right? So the owner is trying to decide. Owner will be deciding which tokens are going to be the reward tokens. So he can set all those reward tokens here from here. This is a setter function. So this will actually check all the if conditions, and all the if conditions are actually good to go. It will go on here. It will just push the reward tokens into the reward tokens array, and also set the reward tokens added to true, and then last updated time to block.timestamp. So the thing is, while looking at the reward system, you'll have to keep that in your mind, that any reward token can be a USDT or USDC. So there are some tokens that has blacklisting properties, right? So that naturally comes into your mind, that if you're staking and the reward tokens are USDT or USDC, and you are blacklisted for USDT and USDC, then you won't be able to receive the rewards. So in that case, that would have been also a vulnerability, right? That would be the case where user won't be able to receive the reward tokens because they are already blacklisted. But let's say there is a function that is that is a function that is delivering all those rewards, transferring all those rewards to all the rewards receivers, and that safe transfer is being done in a for loop, right? Let's say, so if one of the user is blacklisted, the transfer to all other users won't be happening, right? Because one of the user is blacklisted and the function will revert, right? In that case, that was also a vulnerable section, right? Maybe a high or maybe a medium, whatever the context is. Get log duration is a getter function. I mostly just skip from the getter functions. Then here it is claimable rewards. You can see what this claimable reward is doing. It is basically returning you the rewards data, and an array of rewards data is struct. So it is basically returning this value, right? Claimable rewards. So how much your rewards are, that can be claimed, right? Then you come to this stake function. Okay, so this is the function that is that is an important function, because the user is going to be interacting here, right? So you understand, okay, this is stake function. So user is coming and he is trying to stake here, right? And then this is internally calling this internal stake function. Here you come and you see this internal stake function. So you just check whether the type index is greater, the first or the second. If any of those are like okay, it'll just revert, right? And then it will update the reward on behalf of so here somebody else's address will be here, so it'll just check and update the reward, right? You have to check this internal function and again all these things are going to be done, and then update reward debt. So reward debt is also being updated here, right? So you'll check these functions. These two functions are very important. Why this function is called first and this is called afterwards, or setting all these things, right? And then it is adding to the list. So whenever you are staking something, it is adding all those tokens to the list, right? So this is like you have to understand line by line what each functions each each line is doing, and then based on that find out the invariants and then try to break it, right? That is how it works. So you have early exit by id. You can early exit, right? When you are staking, you can basically, when you are staking, let's say staking is done for 30 days, right? And you have the option to early exit, but you can only early exit you can only early exit by giving the penalties. So the penalty amount is for the stakers that are exiting early and not after the lock period, right? So they have to pay some penalty, and that penalty is basically calculated in the uh, time based amount, and basically time based amount. And there was one more thing I just forgot. Penalty was, okay, time based and fixed penalty, right? So when you are early staking, when you are early exiting by id, you'll have to give some penalty. So you understand this, okay? So and then exit late by id, you understand this and try to understand everything and how things are going, and what can be, what can go wrong. And you can restake after late exit, you can do that withdrawal. So I found one vulnerability here. So that vulnerability was something like, so this was the only vulnerability I found. Oh, there were two others, but that was, I didn't reported it because those were not as important for this context of this audit. So for me, I started with this. So when I saw a while loop and there was a for loop inside, and this was get logs. So when you see at the get logs, it is also like kind of let me show you when you find here. So this get log also has a for loop, right? So when the limit is less than the log count, it will come here, it will get all the logs, and then for all those logs it will just run a for loop and remove all those logs from here, and then it will increase the limit, which is of no use, right? Because the thing is, if there are too many log counts, it will run out of gas. Either it can run out of gas, or the second problem is when this limit, this while loop is of no use actually, because this for loop will actually remove all the logs from here, and there's no use of like increasing the limit from by plus 10. So this was for me a vulnerability, and I submitted it. Let's see how it goes. And then you can just move on further. You can these are the internal functions, and the internal functions are basically, when you are checking all these functions, you'll check all those. When you are checking, let's say, claimable rewards, you have this earn function, which is an internal function. So when you check the internal function, you will automatically put audit tags, right? So audit okay or whatever you have. So just go line by do the line by line review of each function and find the invariants and try to break it, and also think what can go wrong, right? Don't just see that the developer has just, whatever the developer has written, it will be right. It won't be happening. Sometimes the developers are assuming things that won't be correct, right? So they won't be able to see things that the auditors can see, right? Because the experience is different. Their experience is making, our experience is breaking, right? So this is how you can just review all these functions. And lastly, there are these functions. This is pause function. You can pause the contract, you can unpause the contract, you can recover the ERC20 token. So this is basically safe transferring the tokens to the owner. And And this is it, guys. Like you have to do the line by line review of the contracts. And so for this video, what I wanted to tell is, when a beginner is starting an audit, he might feel very overwhelmed by watching all these contracts. But don't get overwhelmed by all these things. Just try to find which one is the central contract, and try to find which one is the central function to break into. So for this, if it is a staking contract, obviously the stake unstake will be the central point, right? uh, Deposit and withdraw will be the center point. If it is lending borrowing, it will be deposit, withdraw, borrow and repay. These will be the central functions. So find the central contract, find the central function, and try to break all these things, and try to write all the invariants over there, and try to break all those invariants, right? So this is it, guys. This for this video, I'm going to wrap it up now. And if you find this video very helpful, like it and share it. And definitely I'll see you in the next video. Until then, bye bye.